Good morning, all of you. Today we are going to see density calculation. What is the density of a crystal lattice? To know the density of the crystal lattice, let's find out the density of the unit cell, which is same as the density of the crystal lattice. We have learned three types of unit cells: simple cube, BCC, and FCC. This is simple cube. This is a unit cell. This unit cell is made up of how many atoms? Only one atom. Density means mass upon volume. What is the mass of this unit cell? Mass of that one atom divided by its volume. Its volume means a cube if A is the edge length. If A is the edge length, then A cube is the volume of this cube. What is the mass of this unit cell? How many atoms are present in this unit cell? Their total mass. How many atoms are present in this unit cell? Only one atom is present. So mass of this unit cell is the mass of that one atom. But in the case of BCC, in addition to these corner atoms, there will be one more atom at the interior center. So in the case of BCC, the total mass or the mass of that BCC unit cell is the mass of those two atoms. Each atom you have to consider as a sphere. So here, mass of mass of those two atoms means that is a mass of that BCC unit cell divided by its volume if A is the edge length. Now, mass of that one atom, mass of those two atoms in the case of BCC. Now, what about FCC? In FCC, mass of this unit cell in FCC, this is face centered cube. Face centered cube means you will be seeing these atoms at the corners. You will be seeing these atoms at the corners. You see only the green balls. Atoms at the corners, all 8 corners. In addition to these 8 corners, there will be one at the face center, which will give a contribution half to this unit cell FCC. So the total number of atoms in FCC is 4. Means from corner contribution 1, from each face half. There are 6 faces. 6 into half 3 plus that corner contribution 1. So number of atoms 4. So mass of this FCC face centered unit cell is the mass of those 4 atoms. Now what is the mass of one atom? You consider iron crystal lattice, iron unit cell. What is the mass of one atom? We know one number about this iron. That is, molar mass of iron is 56 grams per mole. Means per mole, that is for 6.022 into 10 to the power 23, atom's total weight is 56 grams. So what is the mass of one atom? 56 divided by 6.022 into 10 to the power 23. Let's go for the calculation. So in the case of simple cube, only one atom is present. So density is mass by volume. Mass is the mass of that one atom. Mass of one atom is molar mass divided by Avogadro number. Molar mass divided by Avogadro number. How many atoms are present? Only one atom is present divided by, that is volume. If A is the edge length, volume will be A cube. So this density 1 into molar mass. 1, I'm writing it as Z generally, Z, where Z is a number of atoms present in that unit cell. So Zm, M means molar mass, upon A cube Na is the density. Now let's see BCC. Here density is equal to mass by volume. How many atoms are present? Two atoms are present. 2 into molar mass. Molar mass, I am writing it as capital M upon A cube Na. This 2 I can denote as Z generally. Now, what about FCC? Eight corners. In addition to these eight corners, center of each face. Center of each phase, one atom is present. So altogether, the total number of atoms in this FCC unit cell, this is FCC, this is BCC, this is simple cube. So in the case of FCC unit cell, the density D is equal to this mass upon volume. How can we write the mass? That is 4. Number of atoms in FCC is 4 into the molar mass upon A cube Na. So generally we can say density is equal to Zm upon A cube Na. Zm upon A cube Na. In the case of simple cube, only one atom is there. In the case of BCC, two atoms are there. In the case of FCC, four atoms are there. Mass of these unit cell is the mass of these atoms. In the case of simple cube, mass of this unit cell is the mass of that one atom. In the case of BCC, mass of that unit cell is the mass of those two atoms. In the case of FCC, the mass of unit cell is the mass of those four atoms. So mass divided by volume. What is the volume? If A is the edge length, A cube is the volume. And mass of that one atom, that is molar mass upon Avogadro number. Molar mass upon Avogadro number. Now let's see the calculation. You should take care that this molar mass unit is grams per mole. Molar mass unit grams per mole. Let's see one question. Silver forms CCP lattice. CCP means FCC. Silver forms CCP lattice. And X-ray diffraction studies. X-ray diffraction studies. Show that X-ray diffraction is an experiment to determine the edge length, a cell dimension or cell edge, means to find out the value of A. X-ray diffraction studies show that the edge length of its unit cell is 408.6 picometer. One picometer is 10 to the power minus 10 meter. That means 10 to the power minus 10 centimeter. 1 picometer is 10 to the power minus 10 centimeter. Calculate the density of silver metal. Calculate the density of silver metal. So density is equal to Zm upon A cube Na, which is equal to, this is FCC, so Z is equal to 4 M. What is M? Molar mass. Molar mass of silver that is given. They have given atomic mass. Atomic mass of silver is equal to 107.9 U. They have given atomic mass. You can get the molar mass by changing the unit to grams per mole. So 4 into 108 upon Na. What is Na? 6.022 into 10 to the power 23. Now A cube. For A cube, you have to write as 408.6 into 10 to the power minus 10 whole cube. Minus 10 whole cube. After calculating, you will be getting the answer as 10.5 grams per cc. So calculation is a little tedious process here. You will be getting easy calculations only in the board examination. Nowadays, logarithm table is not provided because they are giving easy calculations. So density is equal to Zm upon A cube Na. Z is the number of atoms present in that unit cell. M is the molar mass in grams per mole. So Z is equal to, that is a number. Z is the number, that is 4. Now 108 grams per mole, and the 6.022 into 10 to the power 23 is per mole. Per mole, so many. Next question. X-ray diffraction studies show that X-ray diffraction studies show that X-ray diffraction studies you don't have to learn. The only thing that you have to know is that by this experiment edge length is found out. Show that copper crystallizes. Metallic solid, copper is a metallic solid. Copper crystallizes in FCC unit cell with cell edge of 3.608 into 10 to the power minus 8 centimeter. In a separate experiment, copper is determined to have copper is determined to have a density 8.9 grams per cc. Calculate the atomic mass of copper. Calculate the atomic mass of copper. Now, D is equal to Zm upon A cube Na. That is the density. Now, what we can find out? We can find out the molar mass. We can find out the molar mass and change the unit. It will give you the atomic mass of copper. So, molar mass is equal to D A cube Na divided by Z. What is density? Density is equal to density is 8.9 grams per centimeter cube into, with the unit I am showing, a cube, that is 3.6 into 10 to the power minus 8 whole cube centimeter cube divided by how many atoms? 4 atoms. 4 atoms into 6.022 into 10 to the power 23 atoms per mole. Atoms per mole. So what all things? Atoms get cancelled. Centimeter cube get cancelled. What is remaining after calculation is what? Grams per mole. Grams per mole. So after calculating, you will be getting the answer as 63.1 grams per mole. This is actually what we are calculating molar mass. The question is to find out the atomic mass. Question is to find out this atomic mass. So what you have to do? Change this unit into U. So atomic mass of copper is equal to 63.1 U. Atomic mass is equal to 63.1 U. Now, using the same equation, they may ask to find out the Avogadro number. And finally, you will be getting the answer as 6.022 into 10 to the power 23. Sometimes they ask to find out the nature of the unit cell. Nature of the unit cell means whether it is simple cube, BCC or FCC. So in that case, you have to find out Z value. Z value, suppose you are getting it as 3.99. Then that is equal to, you're approximately equal to 4, you have to say, and you have to say it is FCC. This is FCC unit cell. In some cases, edge length will not be given directly. For example, NaCl. In the case of NaCl, we know that the edge length mean the edge length means that is see this corner one atom is there, and that corner one atom, and here is what? Sodium. The corner Cl minus, Cl minus here, Cl minus here, Cl minus here. In between is Na plus. So edge length means from this point center to its center. This is the edge length. Edge length means from its center, means Cl minus center to that Cl minus center. So in that case, you will see that here capital R and two small r's, small r, and that capital R. So the edge length A is equal to twice R plus R. This is the edge length. So they may give the interatomic distance or interparticle distance. Suppose the interparticle distance what they have given is this much they have given. That means from here to here they have given. So edge length will be double of this. Sometimes they give edge length and they will be asking the interatomic distance. Interatomic distance. Or calculate the distance between Na plus and Cl minus. That means this green length. Calculate the distance between Na plus and Cl minus. Interparticle distance or interionic distance. Sometimes if atoms are the constant particles, then they say interatomic distance. So here, the distance between this Na plus and Cl minus means what I have shown in this green. What I have shown in this green. Sometimes they won't give this edge length. Instead, they give the distance between Na plus and Cl minus. They say like this. If the distance between Cl minus ion and Na plus ion is given as 281 picometer, then what is the edge length? Double of this. Edge length will be its double. What they give? If the distance between Na plus ion and Cl minus ion is 281 picometer. So the edge length, you have to take it as the double, 562 as the edge length. If you calculate the edge length as 562, then the interatomic or interionic distance, that is the distance between Na plus and Cl minus, is just half of that. And another way of question is find out the radius. Find out the radius. For example, niobium crystallizes. Niobium crystallizes in BCC. That means Z value is equal to 2. If the density is 8.55 grams per centimeter cube, calculate the atomic radius of niobium. The atomic radius of niobium. Niobium's molar mass is given 93 grams per mole. Sometimes they give atomic mass, then 93 U atomic mass. If it is atomic mass, they would be giving us 93 U. We need only that value. So here the question is atomic radius. So first you have to find out the edge length. After finding out the edge length, using that equation, in the case of BCC, the radius edge length ratio is 4R is equal to root 3A. First you have to find out A, then substitute in this equation and you have to find out the radius, that is root 3A upon 4. So let's first find out A. From density equation you can find out A. Density is equal to Zm upon A cube Na. Z BCC, that is 2. So density is what? 8.55. 8.55. Z is equal to 2. Molar mass is 93 divided by A cube. A cube. So finally you have to find out the cube root. Na 6.022 into 10 to the power 23. So A cube, you are getting A cube after calculation you will be getting 36.1 into 10 to the power 6 picometer cube. So A is the cube root of this. Cube root of this is 3.3. 3.3 into 10 to the power 2 picometer. So once you get this A, then you can find out this R. 4R is equal to root 3A. The relation is for BCC. So we are doing like this. So R you will be getting as, that is root 3A upon 4, which is equal to root 3. What is A? A is equal to 3.3 into 10 to the power 2 upon 4. You'll be getting it as 143 picometer. Thank you.